All right, so hey everyone, I'm Noel. We're going to talk about building personalized ad experiences through iteration. So iteration from the tech backend side all the way to testing and iterative product development, kind of closing the loop. And I'll start off with two scenarios. So first, imagine that you're running, you're really kind of in a groove, and an ad comes on that is maybe totally irrelevant to your experience. It really throws off your mood. This has definitely happened to me. It's probably happened to you as well. That's a terrible ads experience. That sucks. Second scenario, imagine that you're working, you're studying, you're listening to classical music, something like that, and you get a loud rap ad or a loud rock ad. That's also a terrible user experience. So Kinshuk and I work to improve the free tier here at Spotify. The free tier is ad supported. But we don't want the ads to be contrary to your music experience. Music is something that you carry with you throughout the day. It's something that you kind of match with your mood, you match with your activity. It's something that's really personal, and Spotify is trying to build a personal music product. We have radio that's personalized to your taste, personalized to what you listen to. We have this browse section that's filled with custom tailored playlists that are supposed to go along with your mood, go along with your activity. Our view is if your day with music looks like this, if it looks really varied and you're using music for different reasons in kind of a utilitarian way throughout the day, match your activity, match your mood, why do your ads look like this? Why are they monotonous like this? So at Spotify, we serve a couple different kinds of ads. We serve music ads, which we call label ads, which could be promoting the latest electronic music album. We also, of course, serve commercial ads for brands. So say we're serving an electronic music ad throughout the day. You're hearing it no matter what you're doing. Sometimes we might get the experience right. If you're working out in the morning, that's not a bad experience. If you're trying to study or you're trying to focus at work, that's a terrible experience. So that's the problem that we're trying to solve here on the personalization team. And we hear this kind of thing from users all the time. Like we have a screen up with Twitter and Facebook streaming in. When we're watching people talking about this, Spotify ads are really killing my mood. With all of this tech, can't you figure out a better way to match my music and my ads? We totally hear you. These people deserve a better user experience than the one that they're getting. Here are a few more quotes. I hate pop music. Why am I hearing pop music ads? I hate rap. Why am I hearing rap ads when I'm listening to something else? These people deserve a better user experience than the one that they're getting. And we don't just hear this from users, we also see it empirically in the data. So this is a graph of the distance between the genre of music that a user is listening to at any one given moment and the genre of a music ad that they were served in that moment. Right? So as we move further toward the left, the distance is further away. As we move further to the right, distance is closer between the ad and the music. And we see click-through rate in green here, and then the number of ad impressions that we're serving in blue, if that all makes sense. So we see as the distance gets better, as the ad and the music that the user's listening to get closer, the click-through rate increases. Like that's something that we cannot deny. We are definitely improving the user experience as we make that distance smaller, but we also know that most of the time we're serving a moderate to maybe even negative ads experience. Like we're not in a place where we want to be. So this is a clear opportunity to improve the product. Here's another example of just empiric data. This is from a survey that we put out a couple of months ago where we asked people, when are ads most disruptive, when are ads most annoying? And we see during a romantic moment, partying with friends, when I'm with other people or when I'm trying to focus, that's when I don't want to be hearing ads. Ads aren't so bad, they're less disruptive when I'm commuting or when I'm waking up in the morning. So this shows us another clear opportunity to improve the user experience. And then finally, this is the result of a k-means clustering analysis that we did on a bunch of features related to how people use Spotify during an individual session, right? So we see some clear session types here indicating that people are using Spotify, they're using their music differently in different situations. Here in the top left, for instance, you can see 40% of our sessions are short sessions where the user is looking at the phone a lot at the very beginning. That's what these blue bars represent focus of the iOS app. They're looking at the app a lot in the beginning, then they put the app in their pocket. And maybe they're running or working or whatever, but they're not looking at Spotify anymore. So we know that people are using Spotify in all of these different ways, and we're trying to custom tailor our music product to these people. We're trying to respect the modes that they're in. We should be doing the same thing with our ad product. So that's the problem. I'll turn it over to Kinshuk to talk about tech.
Thank you. So as Noel explained, we found a lot of user pain points a few months ago, both through anecdotal evidence, through data backing some of those pain points. So we formed a team to tackle some of these problems a few months ago. And when we started off, we knew there were a bunch of different pain points, and we wanted to come up with a framework to solve these different product problems in a very sort of systematic way, so that we're not investing a lot of time and energy in building things which probably won't add a lot of value. So borrowing the ideas from lean startup principle, we followed this very agile philosophy of figuring out different user pain points, which would be the user stories, and then coming up with hypotheses, different kinds of hypotheses and goals to see whether we can build products and validate those hypotheses. So we work in this constant loop of constantly discovering different pain points through data, through user feedback, which get converted into hypotheses. Then we typically do not build a very extensive, or rather start on a very extensive project. We try and build very minimal products and run A/B tests to make sure that the hypothesis is validated. There's actually value in building those products going forward, and we keep iterating on them. So to give you an example of what that means, so if you saw some of those tweets earlier and some of the data points, a lot of our users complained about ads being totally non-relevant in their musical context. So for instance, someone is streaming classical music and then they get an ad for rap artist promotion, which does not make a lot of sense. Ideally, if you're listening to classical music and if there's a music promotion for an album which is for classical music, that would be more relevant. So that was one of the hypotheses. Something else, another example is users typically want ads, musical promotions, to be targeted to their taste profile. So for instance, historically, if I listen to a lot of jazz music, I wouldn't probably enjoy an artist promotion for an artist who plays a lot of metal. So these are the examples of some of the hypotheses we come up with. And once we have these hypotheses, as a product and engineering team, we sit down and try and figure out what are the products that we need to build to validate those hypotheses. So for the first example of context-aware ads, we figured out that our ad targeting based on the musical context or the genre context of a user is broken, and to fix that, we need to build an ad targeting system which can deliver ads which are really relevant to the real-time genre context of a user. Similarly, for taste profiles, we need to also process users' historical genre preferences, so on and so forth. So once we identify these are the products that need to be built to validate the hypothesis, we do standard A/B tests with a control group and a couple of variations to see if the hypothesis is actually true. So having come up with this nice agile way of evolving the products iteratively, other challenge that most people in product engineering teams face, and I'm sure a lot of you have faced this problem, is how do you keep up your infrastructure with these changing product requirements? Today you're starting to build out something, and by the time you're actually finished building those systems, the requirements might have changed. And in our experience, what worked really well was having a good high-level overview of what we want to achieve, and then we kept iterating on the infrastructure to keep up with the product requirements. So when we started out, we had a good belief that going with the microservices architecture where there's isolation of concern would help us build and evolve systems independently of each other. At the same time, we can make tech choices based on the requirements of the product that we're trying to build. So at a very high level, this is what we envision. So we're going to have an ad server which exclusively focuses on delivering ads, and has a bunch of standard ad serving features like pacing of an ad, so that it delivers over a fixed period of time evenly It has rule management features built in. But it wasn't necessarily going to focus on the requirements of targeting an ad to a user. So we had we built a different service which exclusively focused on coming up with newer targeting features. And that service was backed by a user attribute store, which would keep getting incrementally new kinds of user attributes on which we could target ads. And to complete the feedback loop, we needed a good log collection system, a good log processing system, which would actually help us process these events that get generated by users. If you look at this architecture at a very high level, if you look at the components on the lower half, most of those things are standard backend services that many companies build. We build them too, and most of that was built on top of in-house sort of backend infrastructure that we have. And for a variety of reasons, we have like an in-house protocol that we use for communication between backend services. So we ended up using a lot of in-house technologies for building that backend infrastructure. For this specific talk, what would probably be more exciting and relevant to you guys would be, the components in the upper half, which are, the data infrastructure components that we've used in our architecture. So some of the boxes that I'm going to fill in are going to be log collection, log processing, and the storage system that we use for storing user profiles. So going back to our product iteration, the first hypothesis that we had was to build a product for delivering context-aware ads. For that, we had to build a real-time targeting system which could deliver genre-targeted ads. So before I dive deeper into the tech choices that we've made for filling in these boxes, the log collection, log processing, and data storage, what I'm going to do is I'm going to run you through a quick evolution of our tech stack as we made different tech choices over a period of time to satisfy our product needs. And once I'm done with that, then we can, I'll be diving deeper into the specific reasons of choosing these technologies. So in the V1, when we were trying to actually solve the problem for real-time targeting, we started off by using Kafka for log processing, log collection. We used Storm, Apache Storm for log processing, and we used Memcache because it was really easy to set up and store, basic targeting key value parameters for the storage of user profile. So once this basic product MVP was built, we started running experiments to validate the hypothesis that there's really value in building context-aware ads. In the meantime, while our experiments were running, we in parallel started working on the next hypothesis. So we weren't wasting any time. While we kept working on the product iteration, we started in parallel evolving our tech infrastructure as well. So the second hypothesis was, let's make sure that the ads are targeted based on, historical musical preferences of a user, their taste profiles. For that, what was necessary was a batch computation of historical logs. So we wanted to analyze users' logs from weeks and months before. So we needed a batch targeting, batch processing framework for all our logs. And for that, we ended up choosing Apache Crunch. So at this point in time, while we were still evaluating the first hypothesis, we ended up completing, we finished building up the second sort of iteration of our architecture, where we had sort of built a Lambda architecture where we were processing both real-time and batch logs and actually generating user profiles. And the storage was still memcached. At this point in time, and we call this version 2.5 because we were sort of in the middle of analysis of our hypothesis. So our experiment for context-aware ads had finished by that time, and we found real value. We found engagement lift by actually targeting the ads based on users' context. So we saw that there's definitely value in continuing to build this product. And with our current storage sort of solution, we didn't have a bunch of nice properties that you would want with some kind of storage. We didn't have persistence. We didn't have like a rich schema that we could use for a bunch of other operations. So we thought, since we want to improve our current infrastructure and make it more scalable, we started considering a bunch of other NoSQL storage options and settled for Cassandra for storing these user profiles. If you look at this diagram, at this point in time, we're still reading the user attributes from Memcache, but we are actually writing these attributes both to Memcache and Cassandra. So while we were in this phase, what we were essentially doing was benchmarking the Cassandra's read latency, because we had concerns about that, and actually evaluating that technology for this problem. And by the time we had actually done the benchmarking, we were happy with the results. We eventually transitioned over to Cassandra completely. All the reads and the writes were happening from Cassandra. And this is how our current version 3.0 for the targeting architecture looks like. So hopefully by sort of looking at this evolution, you've seen that how we've managed to keep iterating on our architecture and product at the same time without necessarily blocking one or the other. And we didn't have to stall any of the operations. We could continue working iteratively. So let me now dive a bit deeper into the choices that we've made for each of these technologies. So let's start with log collection. So today we've chosen Kafka, Apache Kafka for log collection. For those of you who've not worked with Kafka before, if you go to their introduction page, this is how they describe themselves. It's a distributed, partition, replicated commit log service. The way I think about it is, it's a distributed message queue with some nice features like PubSub. It has some nice guarantees like fault tolerance and ordered message delivery in a partition. And the reason we ended up choosing this over some of the other solutions was that over the past 2 or 3 years, Spotify as a whole has tried different log collection solutions. We've tried Apache Flume, we've tried some homegrown solutions, we've tried Kafka. In the meantime, Kafka has evolved as well. It has become a bit more mature. And based on our requirements, specifically for this problem where we wanted to process logs both in real time and in batch mode, sort of Kafka fit the bill. We have a lot of in-house expertise in Kafka. We didn't want to use a solution which was different from what we use for regular log collection for the rest of the stuff at Spotify. So Kafka seemed like a very obvious choice, and we settled with it. So in this diagram, if you look, the first box for log collection, we settled for Kafka, and we know that it's well supported within Spotify. So that ended up being our choice. In this architecture, the V1 architecture, the choice for a log processing framework was Apache Storm. Again, for those of you who've not worked with Apache Storm before, it's like it's a real-time stream processing framework. It's almost like MapReduce with a lot of reduce steps. It has some nice guarantees for fault tolerance and message delivery. And the nice thing about Storm is that although it's still a bit immature and it's still at version 0.9.2, but it's far more mature than some of its competitors. So while evaluating this solution, we saw what's its current usage, what's supported by the community, and it's been tested at scale at Twitter. And its competitors like Apache Samza or Spark Streaming are still a bit immature and do not give us the kind of guarantees in latency that we require for some of our real-time problems. So Apache Storm seemed like a good solution. We've been working with it for over 6 to 7 months, and so far we've been happy with the performance. And the nice thing about it is that it has a very engaged and active community supporting it. So since version 0.8.1, it has some nice testing support built in. For those who've not used Storm before, there are concepts of bolts and spouts, which are essentially processing units, which can do a bunch of operations like filtration, aggregation, joins, etc. And the way you would wire them up is called a topology. So it's very easy to test these topologies locally without actually deploying them to a cluster, which is really nice. You can write Storm jobs in both JVM and non-JVM languages. We mostly use Java, so it's really easy to write unit tests. And since the latest version, there are some nice visualization support as well. You can see these topologies, how they end up looking on your dashboard. So it's really easy to understand how the message is flowing through your graph. For the next sort of tech choice which we made, which was for batch log processing framework, was an interesting choice. So for a long time, Spotify is probably, if I'm still right, has the biggest Hadoop cluster in Europe. And for the longest time, we've been using Python MapReduce, Python streaming MapReduce for computing data. But over a period of time, we started realizing a lot of pain points with that. And as a company, we've settled for using Apache Crunch for most of our MapReduce computations. The nice thing about Apache Crunch is that you are not necessarily dealing with very low-level map and reduce operations. You're dealing with high-level constructs like filter, join, etc. So for those of you who work a lot with Hive and have SQL-like experience, it's easier to make the transition to writing these batch jobs. A little bit of info about Apache Crunch. It has some nice data structures. The lowest sort of data containing abstraction is something called as P collection, which is an immutable collection of all the entries of type T, which T can be any kind of data set. And then you can do a bunch of interesting operations like map and combine, etc. So without going into the details about Apache Crunch, what I would say were some standard features that made us choose Crunch over standard Python streaming MapReduce was the ease of testing it and really good performance. We benchmarked and we found like 5 times better performance as compared to similar MapReduce jobs in Python streaming. And some of the nice things are like type safety and support for high-level operations, which the Python streaming MapReduce doesn't have. It also has like a good support for Avro records, which we use internally. And if you look at this, sample job, literally in like reading these 10 lines, you can figure out what's the gist of the whole operation. You can write your custom filter operations and utility methods, but if you want to just understand what the job is actually doing, it's not that verbose. It has good testing features as well, so this is like a standard unit test that you would write for it. So at this point in time, we had made choices for both the batch and real-time log processing frameworks, and we were thinking about coming up with a more persistent data storage for storing our user profiles. So earlier we started off using memcached because it was really easy to set up. It was a simple key value store. We could just read and write really fast, set some TTLs, and that worked really well in real-time use case. Not so much in the use case where we had to actually store data for a longer time. So we needed more persistence. We needed richer schema to sort of work on complex use cases, which probably became a bit difficult in memcached. But our only concern was that the reads would be probably slower. But after doing some benchmarking, we found that the reads are not that bad, even for the real-time use case. So we ended up choosing Cassandra over memcached. Now, of all the NoSQL solutions, the reason we chose Cassandra specifically was that, again, it has an active community. The project itself is maturing, and specifically at Spotify, we have a lot of in-house expertise in Cassandra, and we use it quite a lot in other products as well. So it was sort of a natural choice. So today, this is how our system looks. It has evolved, and hopefully it gave you some insight about how we ended up building, rather coming up with like a higher level vision of how the architecture should be, how we fill the boxes with different technology stacks. And if you were to zoom out a little bit, the flow of the events in our system today look like this. So we have all the logs flowing in through Kafka. They get stored in HDFS for batch computation. Kafka streams those logs to Storm, and Storm and Crunch respectively process these log messages in real time and batch, and then eventually the user profiles are updated in Cassandra, where all the reads happen from the ad targeting service for serving personalized ads. So Noel is going to talk us through the rest of the part about how we actually end up testing these features once we build them.
Right, so that's iteration in the tech backend. I'm going to talk quickly about iteration, in testing. I'll go quickly back to this. So our flow here is we start with our user stories, the problems that we see out in our user base. We go from there to hypotheses and goals. We build product MVPs with as little engineering effort as possible so that we can loop back and we can learn. And every cycle through here should end with a test. If we're not testing and learning, we have failed, basically. But the very first kind of test that we can run, test phase 0, if you will, is before we build anything, just looking at the data that we have. So I'll come back to these two graphs and what they told us about users and their experience with ads and what they told us about what we might build. This gave us the direction to then begin actually building before we put in any engineering effort, before we even started on our product MVP or started defining our product MVP. So from that phase 0, we go to looping through this as quickly as possible. And that takes the form of A/B testing. So an example of an A/B test we might run, that we ran recently, is serving a rap ad to people who are listening to rap versus people who are listening to something completely different. Or serving an ad that is study-oriented to one of our focus playlists versus serving it against a playlist that's completely unrelated to studying. Those are the kinds of A/B tests that we run once we get into this loop. So when we're running our A/B tests, how do we define what's a success? Like, how do we evaluate our results? Well, logic would tell you that if you can't move your top level metrics, if you can't move metrics like how long are people staying on the service, or are people upgrading or not, we call these our AAR metrics: acquisition, activation, and retention. If we can't move AAR, like, why are we building stuff? Why do we continue testing? We found, though, that these higher level metrics are really hard to move, and it's even hard to move metrics one tier down. So we define one tier down as being our vital signs metrics. These are metrics like how long did somebody use Spotify during the day? How many streams did they listen to during the day? We've even found that is hard to move in a lot of areas, and that's not just ads. It's all across the company, and I'm sure you've seen similar stuff. A lot of the movement happens kind of down here in your lowest level metrics. For us, that's our ad-specific metrics. So if we can't move this top level stuff, is it worth continuing to test? And our answer is yeah, it is, as long as you can see constant improvement in the user experience over time. So this is kind of how we conceptualize this. There is a threshold of user experience at which you will impact your top level metrics. There's a threshold at which you will actually cause people to stay on Spotify or your service or leave or upgrade, whatever it is. But that threshold is obscured by any number of factors. For us, it's people liking Spotify in general and having pretty high ad tolerance. So if I'm a user and I like talking with my friends on Spotify, sharing music, creating playlists, I'm not going to notice or care so much about what the ads experience is like, even if we make it 5x better. But at a certain point, we will actually begin to impact that. So that's why our focus, at least right now, is on ad-specific metrics, if that makes sense. And then diving into what those metrics look like, because we're so focused on user experience, we don't just look at the upside of advertising, like you might kind of think if you're looking at analyzing the impact of a banner ad or an audio ad. We look at positive and negative signals. For us, it's important to see whether people are responding to the ads, but also whether people are annoyed by the ads and trying to avoid them. We need to balance that out. So for us, positive signals are signals like, of course, click-through rate. We can also see downstream effects. Like if we promoted an album, did people actually go and listen to that album 3 days later? Those are the kinds of things that we measure and try to look at. That's positive. On the negative side, we know from surveying users and from looking at data that volume for us is somewhat of an annoyance meter. If people don't like the ad, they lower the volume. I'm sure you've had this experience. So we look at volume changes. We look at audio output. Did people, did users unplug the headphones, right? That kind of thing, which is a pretty strong signal. And eventually, we're hoping to roll all of these into a series of ad quality scores using a classification algorithm where we can say, you know, this ad or this ad experience was X% annoying or X% positive compared to all of our other ad experiences. So that's how we evaluate tests, and that is all we have for you. So thank you so much. We're hiring if you want to work on these problems or something similar, and let's take some questions.
On the, I think the ad volume one is an interesting one.
Yep.
Are you limited to just, you know, in the actual application itself to being able to analyze the volume, or is it like externally being able to see it, somebody actually hit the mute on the keyboard?
Yeah, okay, so the question is, how limited are we in measuring volume changes? The answer to that is it's totally dependent on the client. So on iOS, it's different than Android, which is different than desktop. We have more or less freedom depending on the client. And one of the really interesting things about working on the ads team is we do work across all of the clients, and we do have to kind of generalize our metrics across all of those different kind of back-end infrastructures. So it depends. Yes.
The graph you showed with the distance, the net distance, like how do you actually measure this? Like, for example, when you say classical music, the whole people at like this, how do you measure that?
Right. So in that case, the question is for that graph where we showed the similarity between the ads and the music that the user was listening to. How do we determine distance if it's not a music ad? That graph was just for music ads. I think that eventually we can probably get to a place where we're saying, if you're listening to, or maybe if you're running and you hear a Nike ad, that's a close similarity, and something else is far away, but we're not there yet.
What kind of difference do you see between the best ad experiences and the worst ones in terms of click-through rate?
So what kind of difference do we see between the best ad experiences and the worst in terms of click-through rate? I'd say you saw the whole range there in that graph from the WTF, which is near 0. I mean, unfortunately, I can't talk about actual click-through rates, but up to 10, 20x when you get to the best ad experiences. I mean, we think about music ads, if we just focus on that, in their very best place as being kind of like content, kind of like music recommendations. And we're seeking to build an infrastructure that's similar to our music recommendation infrastructure for ads so that they feel personal and like something that you would like to pay attention to and click on. Yes?
Talk about the size of the
Okay, so the question is, we would like to know a bit more about our Storm cluster. So right now we have a cluster, pretty small cluster actually, which we are running on 6 hosts, and it's a dedicated Storm cluster. We are running just one topology for targeting, and as you saw in the diagram quite a while ago, this is roughly how our topology looks like. So we have a bunch of tasks, which could be either spouts or bowls, processing different kinds of things. And on an average, I cannot speak about the volume of events that we see, but on an average we see hundreds of thousands of events per second, and we are running 0.9.2 on Ubuntu. I guess was that it, or do you want more information? We can take that offline and discuss the specifics. Yeah. What are we using to read from Kafka?
Yeah, the diagram we have.
Okay.
Kafka with an arrow going right to Storm with an arrow going up to HTTPS.
You're talking about this diagram in particular.
Yeah.
So I specifically don't know. So we have like a dedicated data infrastructure squad working on data collection, which focuses on that part of the pipeline for sort of writing Kafka messages to HDFS. So unfortunately, I don't know the specifics of those, but I can find that out and we can discuss that later. Yeah, later. Sure. Go ahead.
In terms of targeting, are you doing pre-targeting and also real time?
So the question is, are we doing pre-targeting or targeting in real time? So if I understand your question correctly, are you asking like, do we tag users as, intenders for certain kind of ads in advance, or?
Are you kind of assigning ads to users for
No.
that, or are you doing that?
So the way it works is like we assign users with different tags. So we, some of the tags could be basic, regular tags like the demographic tags like age, gender, etc. And then some of them are more custom tags like an ad is, has high affinity to classical music, for instance, those kind of things. And the assignment of tags happen both in real time and in batch mode. So in this diagram, the Storm pipeline generates those tags per user in real time, whereas if you're doing any kind of historical analysis, those tag generation happens in sort of batch mode. Once those tags are assigned and stored in Cassandra, the rule matching happens in real time. So the ad server, when it makes a call to ad targeting service, it says like, give me all the relevant tags for the user. The ad targeting service does some kind of filtration and sort of decoration of responses, but it's literally reading from this data store. And the ad server does the rule management or sort of matching. It says, okay, I have all these ads targeted to users who should be listening classical music, and these are all the users who have been tagged with classical music tags. So then it does the matching. So the users are sort of, in that sense, pre-assigned with tags, but the matching happens in real time. Your question?
Yeah, sort of on the testing front, I was wondering if you, through some other previous project, like validated sort of conceptual draft that you can focus on low-level metrics and eventually affect the ones that you really care about.
Wanna take that?
Sure. Yeah. Okay. So we ran a previous test where we served different ad loads and frequencies to users. So we increased the ad load a little bit for some users. We decreased the ad load a little bit for other users. Those differences took a long time to actually manifest themselves in the AAR metrics, but we saw first people, talking about having a different ad experience, a bad ad experience or a good ad experience in our NPS data and on social media. We picked that signal up kind of first. Then we definitely did see changes in the vital signs metrics and the number of streams over time and the click-through rate. And then eventually, after a few months, we saw changes in the AAR metrics, but they took a while to show up. And we would have probably turned the test off if we hadn't seen those kind of primary indications that we would see something bigger in the future. So yes.
I didn't hear before, but did you say, I was curious about how you had the attributes of the tag and the actual advertisements. Like, how did you learn how to do that matching appropriately?
Okay, so the way, so if I understand your question correctly, the question was, how do you determine what tags need to be applied to a user and what tags need to be applied to the advertisement, and how does
the advertisement, yeah.
the advertisement? So right now, the way it works is those assignments are not necessarily done in an automated way. You would manually go and assign certain things. So for instance, if for musical ads, it's sort of very obvious. So if you're doing an artist promotion for an artist who plays a lot of hip hop music, it's easy to assign that user or that artist genre of hip hop, right? So that's very obvious. For brands, it's a bit more complicated. So some brands have a lot of insights about what their audience is like. So for instance, and I'm just making up this example right now, so don't take my word for it. For instance, Red Bull might say, okay, our users are adventure users and they like the kind of music which represents adventure, and then they might assign themselves a genre which would match with that. The way it would start working in future once we have a lot of data, because right now it's a cold start, we're building these features, we don't have a lot of insights about these brands, what works for them, what doesn't work for them. But in the future, once we have a lot more data, we can analyze what are the relevant tags for different kinds of brands and advertisers, what works for them, what gives them lift and engagement, and then we can start programmatically tuning and changing these things in real time, as opposed to like statically defining them in advance.
One of the, I guess, benefits that you guys have is that you have a user login as opposed to a cookie ID, where you're not guessing, you can actually see changes. What are the kind of things you notice as far as cross-device performance goes, like desktop versus mobile? I mean, have you all looked into that, or is there any noticeable changes?
I can start.
Changes in. So the question is, what kinds of differences do we see cross-platform? Because we can track the user from their iPhone to their desktop. What kind of changes are you kind of thinking of?
Is there like any noticeable performance? Like, is there generally higher CTR in mobile or things like that?
Yeah, so we definitely do see a difference in CTR across all of our platforms. Some of that has to do with the ad placement on the platforms, which makes testing kind of tricky. If differences between the products are manifesting themselves in your test results, it's something you need to think about and pay attention to and try to normalize out. But yes, we definitely do see differences, and it's something we need to take into account regularly.
So when you do A/B testing, are you doing like the same treatment across all the customers? I mean, or are you influenced from that customer segmentation? Because as you mentioned, like different customers have different tolerance for that. So do you like actually segment the customers? So when you like measure performance?
Yeah, that's an interest. Okay, so do we segment the customers when we're doing the users when we're doing A/B testing? Do we say like these people are really tolerant of ads, so we're going to watch them, and these people aren't very tolerant at all, so we're going to watch them as well? That's a tricky one. I mean, it's something that you always need to kind of you need to walk the line carefully, because if you segment too finely, you'll always find a segment that shows what you want to see, or doesn't show what you don't want to see. But at the same time, you do want to make sure you're getting the full picture. I think I'd say we try to be general, because we do want to know that the changes that we're making are going to make a meaningful impact across the entire user base. But we do moderate segmentation. We do segmentation by country, for sure. Segmentation by age, segmentation by platform is a really interesting one. I don't really like to go more finely grained than that, just because you do get so far down that you'll find a difference, but it won't actually be meaningful. You need to balance what's meaningful with what's detectable, if that makes sense.
Yeah, so maybe just get like 5 or not more than 10. Like utilize, you can like maybe the train the model to utilize the segmentation and download and so on and create that segmentation.
Yeah, that is interesting. We ran a test with 16 segments, and that seemed to be kind of the upper bound of what we could meaningfully kind of analyze. So yeah. Okay.
Thanks.
Well, thank you so much, guys.
Thanks, guys.